Gravity. What is gravity? Gravity is a confusing subject, but I hope we can help you to understand a tad better. Gravity can be looked at as a curvature in space-time. The closer you get to this curvature, the faster you travel towards the object. The reason gravity exists is due to the uneven distribution of mass in the universe. This distorts space-time. This distortion in space-time is usually diagrammed as a flat plane with a spherical curve around the planet or solar mass that it is placed in. The curve represents where incoming masses will be affected by the mass's pull.
The Sun, Moon, and Earth, for an example, all distort space-time. The Earth rotates around the curve, and as long as your mass keeps orbital speed, you will not fly off into space or fall out into the Sun.
The Moon orbits the Earth in the same way, and satellites orbit the Earth exactly the same. Although different from satellites, solar masses don't need boosters to keep orbit speed, because in deep space there is no friction to slow masses down.
Einstein's general relativity describes time as having a very important role in gravity. As an object travels through time, you are compelled to move through space. As you are drawn by this curvature, you pass through time and you begin to accelerate through time and space.
Thus, as you travel in undisturbed space, the slower you travel through time, and as you travel through a curvature in space-time, you travel through time faster as you accelerate towards the object. The greater distortion in space-time, the faster you accelerate. Make sense? We hope so.
But enough of general relativity. What are some cool facts about gravity and its quirks? Cool gravity!
Something you may or may not know is that we all possess gravity. Every single human on the planet. At 1 meter away, a 100 kilogram, or an imperial 220.462 pound person, you are being pulled 1.5 billionth that of the Earth's gravity. This is such a small amount that in an environment with friction, you won't be accelerated towards that person at all.
In fact, theoretically, if you were to collapse a human into its Schwarzschild radius, it would become a black hole. But you wouldn't have to worry about being sucked in, at least from a relatively short distance. This is because a black hole still has the mass of 100 kilograms of a person, and still the gravitational pull is a 1.5 billionth of the Earth.
Did you know that past their event horizon, they have an infinite amount of gravity? Well, the example we gave before has an event horizon extremely close to its singularity, so the spaghettification begins there. This concludes our lesson of black holes. I love spaghetti.